All right, today we're jumping into something that's, well, everywhere you look. We're talking about the science of strategy itself, game theory. And trust me, it's this incredibly powerful way of thinking about how we make decisions, especially when our choices affect other people and their choices affect us.
Yeah, I know. It sounds like the start of a really weird joke, right? But there's a fascinating link between all of these. Just think about it for a sec. In every single one of those situations, you've got people each trying to make the best choice for themselves, knowing that what they do impacts everyone else involved.
And that's the secret. To a game theorist, that's exactly what they are. Games. They're all situations where our outcomes are linked. And once you understand the rules of the game, you can start to figure out how it's all going to play out.
So here's our game plan. First, we'll cover what the science of strategy actually is. Then we'll break down the key pieces: players, strategies, and payoffs. After that, we'll dive into some classic games to see it all in action. We'll figure out how to find the solution to a game, and then we'll see how this gives us a totally new way to look at the world. Ready? Let's get into it.
Okay, so first things first. What do we even mean when we say the science of strategy?
At its heart, game theory is all about thinking strategically. And look, it's not really about chess or Monopoly, not specifically. It's about the logic underneath any situation where the result of your choice depends on someone else's choice. It's a game anytime you have to think, what are they going to do and how should I respond?
Now, to analyze any game, whether it's a business deal or just picking a restaurant, we need to know its three basic ingredients.
Just think of it like this. Who's playing, what moves can they make, and what do they get out of it? If you can answer those three questions about any situation, congratulations, you've just framed it as a game.
First, you gotta have players. These are just the decision makers. It could be you and a friend deciding where to get lunch. It could be Apple and Samsung setting their phone prices. It could even be entire countries at a negotiating table. The only rule is you need at least two players whose fates are tangled together.
Next up, strategies. A strategy isn't just one move. It's a player's entire playbook. It's a complete plan that says, if this happens, I'll do that. Now, in a simple game, a strategy might just be one choice, like I confess or I deny. But in a really complex game, like a corporate price war, a strategy could be a whole series of actions over months. And finally, the most important part, the payoffs. This is what it's all about. It's the motivation. What do the players actually want? A payoff can be anything: money, market share, years in prison, or, hey, even just the satisfaction of going to the movie you wanted to see. We usually boil it down to a number. Higher is better, so we can clearly see what everyone is aiming for.
Okay, enough with the theory. Let's make this stuff real. We're going to look at two of the most famous games in the playbook, and they show off some really classic strategic problems.
This is the big one. You've probably heard of it. So imagine you and your partner in crime get caught. The cops put you in separate rooms. You can't talk to each other. And then they walk in and offer you both the exact same deal. What you decide to do next is going to seal both of your fates.
Let's walk through this chart, because this is where the magic happens. The numbers are years in prison, so remember, a smaller number is what you want. Your choices, deny or confess, are on the left. Your partners are up top. So if you both deny everything, you each get a light sentence, just 1 year. But if you confess and they stay quiet, you walk away free and they get slammed with 10 years. And if you both decide to confess, you both get 5 years.
So, what do? Let's think it through. Imagine your partner denies. What's your best move? Well, you should confess, right? You go from 1 year in jail to 0. Now, what if your partner confesses? What's your best move then? You should still confess, because 5 years is way better than 10. And here's the kicker. Your partner is sitting in the next room doing the exact same mental math.
All right, let's switch gears to a totally different kind of problem. This one's about coordination. It's a classic setup. A couple wants to go out together, but their phones are dead and they forgot to decide where to meet. He wants to go to the football game, she wants to go to the opera.
Now look at these payoffs. The most important thing for both of them is to actually be together. If they go to different places, they both get a big fat 0. No fun. But they do have different preferences. Partner 1 is a little happier at the opera, while partner 2 gets a bigger payoff from the football game. They want to coordinate, but they disagree on where.
So we've got these tricky situations, but is there a way to actually predict what's going to happen? You bet there is. It's all about finding something called an equilibrium.
I mean, this is the whole point, right? We assume people are smart and are trying to get the best outcome for themselves. So knowing that,
can we find a stable result? An outcome where nobody looks back and says, oh man, I wish I'd done something different.
And that brings us to the famous idea from mathematician John Nash. It's called a Nash equilibrium. And the best way to think about it is as a no-regrets outcome. It's a point where, looking at what everyone else did, you're happy with your choice. You, by yourself, can't do any better by changing your mind.
Let's go back to our two prisoners. The Nash equilibrium is right here. Both players confess. But why? Well, let's do the no regrets check. If you're player 1 and you both just confessed, getting you 5 years, could you have done better by switching to deny? Nope, you would have gotten 10 years, so no regrets. And the same logic is true for player 2. It's a stable, if unfortunate, outcome.
And this is the punchline of the whole dilemma. For each prisoner, confessing is what we call a dominant strategy. It's their best move no matter what the other person does. But the tragedy is that when they both logically follow their own self-interest, they end up in a situation that's worse for both of them than if they had just trusted each other and stayed quiet.
Okay, so once you get the hang of these simple games, you start to see them everywhere. It really gives you a powerful new lens to look at the world.
So let's just wrap up the big ideas here. First, these strategic games, they aren't just in textbooks, they're happening all around us, all the time. Second, as the prisoner's dilemma shows us so clearly, what's best for one person isn't always best for the group. This helps us understand why cooperation can be so incredibly hard and why it's so important to think a few moves ahead.
Seriously, once you start looking for players, strategies, and payoffs, you will see them in your job, in politics, even in your own family. The question is no longer just, what should I do? It becomes, what should I do knowing what they're probably going to do? And believe me, that changes everything.